Assalamualaikum and hi. My name is Muhammad Ishaq Zafri bin Zambur, RA23191.
And my name is Ahmad Adam Muaz, RA 23121.
My name is Danish Dalami bin Zumri and my ID metric is RA23229.
First thing first, we gonna talk about equipment that used in multi-speed rotary drilling. Section A, we have a drill rig. It provides a rotary motion downward force to advance the borehole. It can be mounted on the truck, crawler crane, or portable depending on the site conditions. Section B is drill bits. Drill bits have a multiply size and function. For example, drag bits, which means a blade bit used for soft soil. Tricone roller bit is used for suitable for medium to hard soils. PDC, polycrystalline diamond compact bit, is used for very hard formation, and core bit used for collecting rock sample. Section C, we have drill rods, which mean drill pipes. It's a hollow steel tube that transmits torque from the drill rig to the drill bits. It allows drilling fluid to circulate through the system. Section D, we have drilling fluid system. Water drilling mud or air is used to cool the drill bit and carry soil cutting to the surface. It prevents borehole collapse. Section E, we have hoisting system. It raises and lowers the drill rods, casing, and sampling tools. Section F, we have split spoon sampler, used in standard penetration tests to collect distributed soil samples, composed of a hollow steel tube split lengthwise for easy sample retrieval. And the last part is hammer system for SPT. We use 63.5 kg weight of hammer, and the drop height is 75 cm and used to drive the split spoon sampler into the soil. How the multi-speed rotary drilling works? First, the drill rig rotates the drill bits while applying downforce work. Drilling fluid is pumped through the drill rods to cool the bit and remove cuttings. The third is the rotation speed is adjusted based on soil condition. For high speed, we use for soft soil, sand or clay, and low speed for hard soil. As the borehole deepens, additional drill rods are connected. When soil sampling is required, the split spoon sampler is inserted for SPT test. Step-by-step drilling process. Step 1. Site preparation. Set up the drill rig on stable ground and ensure water supply or drilling fluid is available. Step 2. Start the rotary drilling. Attach the appropriate drill bit to the first drill rod. Begin the drilling with the adjusted rotation speed based on soil type. And lastly, pump drilling fluid to remove cutting and stabilize the borehole. Step 3. Advancing the borehole. Add more drill rods as depths increase. Monitoring drilling parameters such as torque, speed, and depth. We're using standard codes in geotechnical testing such as the MS 1056 Part 9 2005, ASTM D1586, and BS 1377-9 is essentially to ensure consistency, accuracy, and reliability in soil investigation. That's all of my explanation. How about your sampling explanation, Adam?
Thank you for your explanation, Ishaq. Soil sampling based on Nation Standard 1056 2005. Soil sampling is a crucial step in geotechnical investigation, providing essential data for construction, foundation design, and environmental assessment. The procedure for soil sampling follow the guideline outlined in Malaysian Standard 1056 2005, which specified the method for obtaining disturbed and undisturbed soil sample while maintaining their integrity for laboratory testing. Disturbed soil samples are those in which the natural structure of soil is altered during the sampling process. However, this sample remain useful for determining physical and chemical properties, such as grain size distribution, moisture content, and ultraviolet limit and classification tests. According to Malaysian Standard 1056 2005, this third sample can be collected using hand auger, rotary drilling, and percussion drilling methods. Once retrieved, the samples are sealed in polythene bags, labeled with important details such as sample number, depth, and the location, and transported to the laboratory. These samples are primarily used for identification, classification tests, including SIF analysis, hydrometer analysis, and plasticity index determination. However, due to disturbance in their structure, they are not suitable for the test requiring in-situ strength and constellation properties. Undisturbed soil samples, on the other hand, are collected in manner that preserve the natural structure, density, and moisture content of the soil, making them essential for the tests that require accurate in-situ conditions such as shear strength, permeability, and constellation. According to Malaysia Standard 1056/2005, for soft to very soft cohesive soil, undisturbed samples are obtained using thin wall sampling tubes with typical diameter of 60 millimeters, pushed into the soil using hydraulic thrust system to minimize disturbance. Once extracted, the samples are properly sealed with paraffin wax to prevent moisture loss. To ensure sample integrity during transportation, they are placed in cushion box and handled with great care. By following the Malaysian Standard 1056/2005, soil sampling procedure ensure accurate and reliable geotechnical test result, leading to improved engineering design, construction, and practice. And that's all from my explanation. How about you, Danish?
Thank you for your opinion, Adam. I will continue for my part. Standard penetration test (SPT). SPT was carried out in accordance with Clause 5.4 MS 1056 of 2005. Back to the method of conducting SPT. SPT is conducted using a split barrel sampler and a self-tripping hammer weighing 36.5 plus minus 0.5 kilogram. The test is carried out at 1.5 meter intervals or as instructed by the site officer's representative and is applicable to all soil types except very soft and soft clays. During the test, the sampler is driven into the ground by dropping the hammer from a standard height. The test is consists of two stages: the sitting drive and the test drive. In the sitting drive, the sampler is driven to a penetration depth of 150 mm or until 25 blows are reached, whichever comes first. Following this, the test drive is conducted where the sampler is driven an additional 300 mm, and the number of blows required to achieve this penetration is recorded as the N value of penetration resistance. If 50 blows are unable to achieve the 300 mm penetration, the test is terminated and the depth of penetration achieved is known. If the initial penetration under the total weight of the drive rods are assembly at 400 mm 450 mm, the sitting drive is omitted and the N value is recorded as 0. The blow counts are recorded for each 75 mm penetration of the sampling tube, and if the test drive is terminated before the full penetration, the depth of penetration for the corresponding number of blows is also recorded. Soil samples recovered from the split barrel sampler and preserved as disturbed samples for subsequent laboratory testing. That's all from me.